Okay, in this example, we're going to look at another geometric problem that also involves quadratics. If you remember from geometry, these are called alternate exterior angles. And I think we're to assume these lines are parallel. And if the lines are parallel, then we know the alternate exterior angles are congruent, which means we can make an equation out of that. So we could say 6x squared minus 9x minus 17 is equal to 5x squared plus 2x minus 45. Remember, when we're solving quadratics in standard form, we do want them to equal 0 and get things lined up. So I am going to move each of these to the other side by doing the inverse operation. That cancels all those out, making 0. And on this side, I would get x squared minus 11x plus 28. Now, this one, I kind of put a little note over here. You can actually do this one two ways. So I thought it'd be kind of neat to try one different way so you could see it. This one happens to be kind of nice numbers because I know two numbers that multiply to be 28 are 7 times 4. And I also know if I make them both negative, I could get an 11 in the middle there. So I could actually do this one by the factoring method. And if I factor that and then set each factor to 0, remember, we're saying we're multiplying two numbers to be 0, so that means one of the numbers has to be 0. I can get the answers of 7 and 4. Okay, now we should check those answers out. If we took 5 times 7 squared plus 2 times 7 minus 45, so you want to substitute those back in and see what kind of results you get. We know angles are bounded. Well, for what we do in geometry, they have to be between 0 and 180 degrees. So this one works out to be 214 degrees. So that's too big for that angle. So let's try it with the other version. Let's do it with the 4. So 7, even though it's an answer, is not a valid answer. So let's try this one out. Let's do 5 times 4 squared, 2 times 4 minus 45. This one comes out 43 degrees. That's a reasonable answer. So one possible way to do this is by the factoring method. We got two possible answers, but the 7, it's not a real valid one for what we're doing in this problem because 214 degrees is too big of an angle. So we're going to say x is 4 and the angle that it would make is 43. So I just thought I'd show you the alternate way to do this if you do it by quadratic formula. Okay, versus factoring. So we kind of already set it up to equal 0. So let's just start here. We know a is 1, b is negative 11, and c is 28. So if we draw our fraction bar, we go negative b, which happens to also be a negative, plus or minus b squared minus 4ac all over 2a. And when I simplify that radical, that makes 9. Negative and a negative here, those are going to turn to positive 11 over 2. Well, the square root of 9 actually works out nice and neat, or if we make a tree, we can see we get a pair and there's nothing left over. So the square root of 9 is 3 over 2. So 11 plus or minus 3 over 2. If I want to break that down, I can say 11 plus 3 over 2. Well, 11 plus 3 is 14 over 2, which is 7. That was the same as that answer there, right? And then if I do 11 minus 3 over 2, I would get 8 over 2, which is 4, which was actually our valid answer. So there's two ways to do this one that would work out. And honestly, if you were just randomly doing a problem, you can just pick whatever way you want. If you're taking a test, though, or something, make sure you're reading the directions and doing the problem the way your teacher